Hello, how are you guys doing today? This is Mr. Roderick. I'm putting out a quick video here for you to talk about absolute value equations and inequalities. We're going to solve absolute value equations, so for equal sign, and we're also going to solve absolute value inequalities, okay? And our working definition to start with absolute value is the distance from zero on the number line. And so that distance, since we're talking about distance, it's always not negative. Okay, so now let's go ahead and get started here. And we're going to use an acronym if you like. Before I get started with this example, hopefully you're writing this example down. You need to write this example down. So as you're doing that, I'm going to write this. Okay, this is something Mrs. Crow taught me back in the day, that um, equal to or greater than signs next to the absolute value is going to lead to an or statement. And if I have a less than sign, I'm going to have a I'm going to have a less than sign. Or excuse me, I'll have an and. All right? So once we know that, getting started with this is pretty simple basically. If we have stuff is 6 units from 0, so it could be the stuff inside could actually equate to positive 6 or negative 6. So that's what we're going to do is we're going to set this equal to positive 6 or negative 6, and those will be the two possibilities for x. So for example, I've got 15 minus 3x equals 6. So we write it just as we see it. Or something else that could happen is 15 minus 3x could be equal to negative 6. That's possible, right? Okay, because that would be 6 units from 0 still. So then we just solve these individually, and we're all set. So quick algebra here. Okay, so x could be 3, or x could be negative or positive 7, excuse me. And those are the two possibilities. And you can check that by putting it back into the example. And that's what you do. Again, the stuff inside the absolute value sign totals up to 6 units from 0. Okay, and that's our basic concept. That's what we're trying to get done here. All right, so let's go ahead and move on to the next example. Okay, example 2. Okay, I need you to write this down. Okay, write down the example, please. Okay, and our initial thought here is my absolute value is in this equation, but there's other stuff around it. And it's almost what you want to do is basically treat the absolute value like a variable. For example, if that were y. In other words, you isolate your rule for absolute value equations. Number one, you isolate the absolute value sign. That's what you do, okay? Algebraically, just like you would with anything else. So, for example, in this equation right here, the first thing I do is I add 4 to both sides, leave the negative 2. I'm just going to work right down here. So negative 5 minus 4, I get negative 9. Okay. And then divide by 2, negative 2. And I get 9 over 2. Now, what I do here is I make a line. Okay. I make a line because now that I've got the absolute value isolated, I'm back to where I was with example 1. I get x plus 9 equals 9 halves. Or the other possibility is this could be negative 9 halves, right, inside the absolute value sign. So I could say, excuse me, x plus 9, that could total to negative 9 over 2. All right. and we just go ahead and do that math real quick. I'm going to work in fractions here for this thing. We get, so subtract the 9, and I get negative 9 halves, which is negative 4.5. Again, not a problem with the 4.5 because that's the exact value. It's not rounded, it's not a rounded number. And then over here, I get a total of 27 halves, and that's negative 13 and a half. So my two possible answers are negative 4.5 and negative 13.5. Again, I'll leave it to you to go ahead and check those two answers. Okay. In other words, you would plug those back in the original setting, and left side should equal right side. Now at this point, I'm going to try this. I've never done this before, but what I'd like you to do is at the bottom of example 2, so I know that you looked at this video, I want you to put Go Browns as they're playing Sunday for the first time this year. See how they do. I have no idea at this point, but that'll let me know that you saw this video. All right? Anyway. All right. Example 3. Go ahead and write it down, please. All right. This one's a little bit long, so hopefully you have some space here. An extraneous solution. This is something we're going to run into here. And an extraneous solution is a solution that you did all the math right. It's derived from the original equation, but it doesn't work. Okay? But it doesn't work. Okay? It doesn't actually create a solution. Okay? So that's what an extraneous solution is by definition. Hopefully, I think you saw that a few times in algebra, but you'll see that more this year. So this is an equal sign again, so I've got two settings. I'm isolated, so I'm really ready to roll here. So I'm going to do this math pretty quickly. I've got 3x minus 4 equals minus 4x minus 1. Okay. Or the other possibility, I've got the stuff could be negative, right? So the stuff inside the absolute value sign could be negative. So to handle that, what I do basically is I go over to this right-hand side and I put a negative in front of the whole thing. So I put it in parentheses. So that's how I handle that with that negative sign right there. Okay? All right, so now to handle this, now I'm ready to just solve these two equations. So I get, let's go ahead and do this math here. We get 7x here equals, add the 4 on both sides, and I get 3, and I get 3/7. And then over on this side, first thing I'm going to do is distribute my negative, and I get 4x plus 1. And then we solve this two-step equation, add 4 to both sides, and I get 5, subtract, I get negative x. So x equals negative 5. Divide by negative 1. Okay, so now what you do, I'm going to be more formal. I'm going to show you the check this time. Okay, so I'm going to plug this on the right here, this negative 5 in, and basically back to the original equation. You go always back to the original equation in case you made some sort of math error along the way. So 3 times negative 5 minus 4, absolute value, equal minus 4 times so this is over here, we've got 19 on this side, and we've got absolute value of negative 19 on this side. And absolute value of negative 19 is 19, so 19 equals 19, right side equals left side. So this is a check. This works. Okay. Over on this side, I'll go ahead and do this in blue. I've got 3 times 3/7 minus 4. And my question is that equal to minus 4 times 3/7? times, or minus 1. And over here, this turns out to be negative 19 over 7. Okay, absolute value. And on the right-hand side, I've got minus 12 over 7 minus 7 over 7. So again, I get negative 19 over 7. But this is absolute value here on the left. So the absolute value of negative 19 over 7 is 19 over 7. And 19 over 7, I'm just going to move this down a little bit. 19 over 7 is certainly not equal to negative 19 over 7, so this is extraneous. Extraneous. All right? All right, so your homework is to just simply have these 3 examples worked out and prepared, and that's really it. So this is, 10, 11 minutes. You should have everything started, and the purpose of this is to give you kind of a start when we go into today, on Monday, when we go into class, you'll have an idea of what we're talking about, okay? And we'll have some more examples that go with this section, but anyway, this will get you started, and I hope you have a great weekend. We'll talk to you soon. Thank you.